Okay, let's move on to peatlands under land use for drawdown. This is ranked by 2050 at number 13, and obviously, as in some of the other items, this one has potential for reducing CO2 as well as protecting a lot of CO2, because peatlands are some of the highest carbon content in below ground soils. More than 50% can be carbon. So it has 21.57 gigatons in reduced CO2 by 2050 and 1230.38 gigatons in CO2 protected, if we can manage to keep them intact, and that's a big challenge in many cases. Global cost and savings data are too variable, so they are not reported here. This diagram here shows some of the plants that have adapted to peatlands. So you need certain amount of soil carbon, but they are typically nutrient poor. So there is water if it's not drained away, but the soils are different. So these plants include sedges, mosses, the carnivorous sundews, so plants that eat insects and so on, orchids, bog myrtle, and many other that thrive in a waterlogged environment where nutrients are scarce. There is a method called Polyculture, which argues for sustainably using degraded peatlands or peatlands that without in a sustainable way, and they can be used according to an FAO report for fodder, fuel, food, medicine, and raw material, which obviously goes into making other things. And FAO provides actually tables of each of these for temperate and tropical regions. So it's a real detailed study that you can look up. Here's an image of harvested peatlands in Ireland as seen from a drone. Peatland ecosystems cover 17% of the Irish Republic and have been hand-cut, what was known as working in the moss, for fuel and winter warmth since Roman times. So they have been exploited culturally for many millennia, couple of millennia. Today, machines employed by the state-owned companies Bord na Mona, I don't know how it's said in Irish, have replaced people, leaving boglands irreparably damaged. That's not good news. In 2015, the company announced it would phase out all peat cutting by 2030 and make a transition to sustainable biomass, wind, and solar power. So peat has so much carbon that under pressure and temperature it would just become coal, of course, eventually over time, but it can also be dried and burned as a fuel, and that's what had been done for a long time for energy, as is mentioned here. Just to get a sense of the structure of the peat, I took this from an FAO report as well here that says data needed for peatland monitoring. Case 1, pristine peatlands, not ongoing drainage. They have other cases where they are disturbed or they are being exploited and so on. But this gives you a sense of the system that sequesters very high amounts of carbon. But you need to know the location and local climate, because that determines various things like the amount of rain, temperature, potential for having water all the time, which is critical for keeping the carbon in anoxic conditions, and methane emissions, CO2 respiration from aerobic consumption of the hydrocarbon, and so on. So here is peatland vegetation forming new peat, which has fire risk factors. I'll show an image in a minute. Water quality of surrounding water bodies, socioeconomic factors, surface level, groundwater level. So obviously when you have surface water, groundwater surfaces, so there is always some water unless it's drained away. What is the area that is being monitored? Biodiversity, drainage-free land use, soil moisture, fertility for temperate and boreal regions, peat depth for carbon storage and so on. So obviously mapping them and then monitoring them is a huge task and very resource intensive. So you can see here an image from this nice blog called Around the World in 80 Peatlands. It's got cute images as well. So this water is important for keeping anoxic conditions and making sure carbon is not respired, so oxygen is depleted, and so on. This website gives a way of how the peatlands are mapped around the world, so you can see global peatland area by country in percentages. Temperate and boreal regions where the temperature remains low throughout the year and is partly covered with snow and ice during some seasons makes it easier to keep the biomass in the ground and convert it into peat and deeper into the soil and so on. But tropical forests, tropical regions with heavy rainfall also can create similar conditions for peats, but they can have high potential for fires and perturbation as well. So these are the different ranges: more than 10% up here, 5 to 10%, less than 0.5%. But you can see a large part of the world has peatlands, which are obviously very rich carbon storage locations, which also means they are potentially vulnerable to perturbations and global warming. And if they begin to release that carbon, obviously you can have very rapid positive feedbacks, just like thermofrost. Right? So this is a fire in a peatland from that FAO study, and you can see that because it's a rich carbon soil, it can burn, and countries like India can have Indonesia can have large CO2 emissions. I think it turns out to be the 4th largest because of these kind of peat fires and the CO2 emissions. Here is a map of CO2 emissions from peatland degradation. So it is just showing emissions from degrading peat in millions of tons of CO2 equivalent. So methane, especially methane, is also converted to CO2 using the chemistry of converting CH4 into CO2 equivalent. So you can see the countries with largest peatland areas and countries with discussed in this report on this Grid Arundel website. So you can see the circles that correspond to various levels of CO2 emissions from peatland degradation, and you can see that Indonesia turns out to be a monster compared to all the others, in the range of 200 million tons of CO2 equivalent. This is from 2017, but there are many vulnerable regions with peatlands. This is from the IUCN, International Union for Conservation of Nature, which gives a nice schematic of draining peatland and its harm on the environment in terms of greenhouse gas emissions, of course, which we talked about, and biodiversity loss. And the disturbances include increased fire frequency, land degradation, and increased carbon loss via water. And then there are other items here that I won't go through. But 10% of the global greenhouse gas emissions from the agriculture, forestry, and land use sectors are caused by draining peatlands. Over 75 years, the number of Sumatran orangutans have declined by 80%. Today there are only 400 Sumatran tigers living in the world, all because of biodiversity loss from peatlands. Smoldering peatland fires can persist for months and continue to burn even after days of rain and under cover of snow. So the underground carbon can keep it going as long as there is some oxygen available for it to continue. When intact peatlands are drained, carbon losses via water increases by 50%. So very simple things to remember. The surface of land can decrease in height by up to 2.5 meters after 25 years of drainage because of soil compaction that happens. Okay. Overall impact: if the total protected area of peatlands increases from 7.9 million acres to 608 million acres by 2050, or 67% of all currently intact peatlands, 21.6 gigatons of carbon dioxide emissions can be avoided. At 608 million acres, peatlands would hold a protected stock of 336 gigatons of carbon, or roughly 1230 gigatons of carbon dioxide if released into the atmosphere. Okay, so there is a factor of about 3.7 to go from carbon to carbon dioxide. That's what gives us those numbers. Though peatlands comprise only 3% of global land area, they are the most organic rich soils. Their degradation would release an enormous amount of carbon. Finances are not projected as they are not incurred at the landholder level, so they are kind of global commons. Plus, not all the peatlands may be yet mapped. There was a huge peatland of the size of UK discovered recently in the Congo rainforest region, so we may still have more to be discovered in terms of peatlands, and then of course more efforts to monitor them, protect them, and make them part of the drawdown.